Good morning, my little poppets, and welcome to another week's learning with Miss Pitt. So today you'll notice you've been assigned a student worksheet. That is your worksheet to edit and add your answers onto in order to submit and for me to mark and give you feedback. So the first things first, please complete the retrieval quiz by going to your student worksheet and typing your answers into the table. Pause this lesson video, go and complete the retrieval quiz, come back to get your answers. So pause me. Okay, so well done for completing your retrieval quiz. Let's get the answers. So what gas do fuels react with during combustion? They react with oxygen. Give an example of a fuel. You could have had any one of those. Remember, glucose is the fuel that we need for our energy. We get it from food. We get heat and light energy from combustion. Remember, another name for heat is thermal energy. An example of a combustion reaction, any type of burning, or remember, respiration. When there's not enough oxygen, we get incomplete combustion. The products of complete combustion are carbon dioxide and water. The gas produced by incomplete combustion is carbon monoxide. Water is a compound. When iron reacts with oxygen, you get iron oxide, and the word equation for complete combustion of methane is methane plus oxygen goes to make carbon dioxide and water. So make sure you're marking your work so you're getting instant feedback on how well you've done, what you've managed to remember. Use the / to tick if you got it right, cracked it in green if you didn't. There's also a little section at the end that says retrieval quiz, score out of 10. Okay, so we're looking at the problems caused by combustion today. So you need to be able to describe what are the problems caused by the products of combustion. Some keywords. We know there are two types of combustion, complete and incomplete. Complete is when there is plenty of oxygen. Incomplete happens when there is a limited supply of oxygen. Carbon monoxide is the gas produced by incomplete combustion, and it is toxic. You will hear the term greenhouse gas today, the main greenhouse gas being carbon dioxide, because it's a gas that causes the Earth's temperature to rise. And acid rain is rain that is slightly acidic or more acidic than usual. Okay, so what do you already know about combustion? What did we learn last lesson? Pause the video. You might want to have 2 minutes thinking time. You might want to get a bit of scrap paper, bullet point, anything that you can remember. So what I think you should remember is combustion is a chemical reaction. It happens when fuels burn. We know that when fuels burn, they react with oxygen. And that oxygen usually comes in the form of from the air. Combustion reactions give out lots of energy. We know that they give out lots of heat energy and they give out lots of light energy. We know there's two types of combustion, complete and incomplete. Complete combustion happening when there's plenty of oxygen and you get carbon dioxide and water produced. And remember, we looked at an example in terms of using a Bunsen burner. When the collar is open, oxygen's being allowed into the chamber to react with methane, and we get a nice blue heating flame. Now, with incomplete combustion, it happens when there's not enough oxygen available for the fuel to fully combust. The fuel doesn't fully oxidize. So rather than getting carbon dioxide, CO2, dioxide meaning two oxygens, we get carbon monoxide. Monoxide, monoxide, one oxygen, because there wasn't enough for two. So Complete combustion produces carbon dioxide. Incomplete combustion produces carbon monoxide. And if the oxygen supply completely runs out, it then produces pure carbon in the form of soot, carbon particles. And it also produces water as well, just like complete combustion. And remember, in terms of the Bunsen burner, when the collar is closed, we are blocking off the supply of oxygen, and that is why we get an orange safety flame. And the orange colour comes from the soot, the carbon particles in the flame. Okay, so the whole lesson's about the problems of combustion. So let's firstly look at the problems with complete combustion. Now, we know that complete combustion, okay, happens when there's plenty of oxygen. We know the general word equation for combustion. We know that all we do is we change the name of the fuel. So we're going to use methane gas. So methane plus oxygen makes carbon dioxide and water during complete combustion. Now, the main problem with this type of combustion is the carbon dioxide gas. Now, remember, we can also use symbol equations to represent chemical reactions. So methane is CH4. What do you think the symbol for oxygen gas is? Good, O2. Goes to make carbon dioxide, which is CO2. And what about water? The symbol for water? H2O. Good. Now the problem arises with this combustion because of the carbon dioxide being produced. Carbon dioxide is what we call a greenhouse gas. It causes global warming. It causes the average temperature of the Earth to rise. Now, if we're causing the average temperature of the Earth to rise, okay, a problem that can be caused by that is melting ice caps and destruction of habitats. Okay, just to go over what global warming is, because obviously this is a big problem with combustion. As I've explained, carbon dioxide is a greenhouse gas. It helps trap the sun's energy and it causes the overall temperature of the Earth to rise. So if you look at this diagram here, by increasing the amount of carbon dioxide in our atmosphere, in the gases around our Earth, we're increasing the amount of the heat energy from the sun staying inside of the atmosphere. It stops it from escaping, it stops it from going back out into space. And that is what causes the Earth's temperature to rise. So a diagram here to show you how the greenhouse gas effect works. So we've got carbon dioxide surrounding our Earth. The sun's energy comes in, it heats up the Earth, and rather than being able to escape back out to space, okay, the carbon dioxide reflects it back to the Earth's surface, causing it to warm up. Now, we call carbon dioxide a greenhouse gas, not because it comes from greenhouses, but because it acts like a greenhouse. A greenhouse traps the sun's energy inside of the greenhouse to keep the plants warm. Just like carbon dioxide is trapping the sun's heat energy, which is causing the Earth's temperature to increase. Now, guys, we do a lot of combustion reactions in everyday life. So, for example, burning fossil fuels in power stations to produce electricity, and all that produces higher levels of carbon dioxide. We are adding to carbon dioxide levels. Okay, using cars and burning petrol in the car engines, and the exhaust, the fumes are damaging the environment because of the carbon dioxide. Remember, increasing carbon dioxide causes an increase in the Earth's temperature, which can have devastating consequences, such as melting ice caps. Now, if we have a lot of ice melting it turns to liquid water, and that causes sea levels to rise. So we're losing land. Habitats are being destroyed. And also, weather patterns across the globe are changing. So global warming is causing destruction of habitats, the melting of ice caps, and climate change. So your first task is to go to your student worksheet and complete these questions on the problems with complete combustion. Pause me, come back once you have answered them for your answers. Okay, so complete combustion produces carbon dioxide. Carbon dioxide causes global warming. Burning fossil fuels, driving cars, combustion are all human activities that add to carbon dioxide levels. And two problems caused by global warming, any one of those answers you would get a mark for. Make sure you are marking your work, so use a / to tick it or correct it if it's wrong. Okay, so now we're going to look at the problems with incomplete combustion. So the problems with incomplete combustion, where we need to know the products first, what's produced. So we know that incomplete combustion happens when there's not enough oxygen. We can show this with a word equation, and we know the products are carbon monoxide, carbon, and water. And again, we can use the symbol equation to represent this reaction. Now, what do you think the symbols are for the products? Carbon monoxide should be CO, well done. Pure carbon, soot, C, and water, H2O, well done. Okay, so what are the main issues with this? Now, the main issues with incomplete combustion are, firstly, carbon monoxide is a toxic gas. It's poisonous to inhale for humans. It's what they call a silent killer. Now, they call it a silent killer because it's a toxic, it's odorless, so we can't smell the gas, we can't taste the gas, we can't see it. It's colourless, it's tasteless, it's odorless. And therefore, we can't detect it if we are inhaling it. Now, if we do inhale it, the problem with inhaling carbon monoxide is it stops your red blood cells, it stops your blood carrying oxygen to your cells. So every home should contain what we call a carbon monoxide detector. Now, that will detect high levels of carbon monoxide because you can't detect it. Okay, so carbon monoxide is a poisonous gas. If it's inhaled, it stops our red blood cells carrying oxygen. And remember, every living cell needs oxygen for respiration. Now, the problems with pure carbon. One problem is that it can cause dirty buildings. Okay, remember carbon's pure soot. Okay, it causes things to get dirty. It can also block pipes as well. So over a long period of time, if you get carbon particles building up, it can block pipes in boilers, for example. Now, also, if you work around lots of carbon particles, if you inhale it over a long period of time, it can actually damage your lungs and cause lung disease. So, for example, in the Victorian times, because children were very small and very cheap labour, well, free, they would use young children to clean chimneys. Okay, where there would be lots of carbon built up, they'd send up the small children to clean them out, and those children would often end up with respiratory problems and breathing difficulties, and a lot of the young children did actually die in the process of cleaning the chimneys, the chimney sweepers. Now, remember, guys, if you inhale carbon particles through your lungs, okay, the carbon particles can build up in your lungs and settle and cause lung disease. Now, this is an image of the windpipe, where carbon particles have been inhaled and over a long period of time have damaged the tissue, the lining, the tissue lining within the lungs and within the windpipe, within the trachea, the windpipe. Now, water doesn't really have any negative consequences upon the environment. So within complete combustion, we've got carbon monoxide, which is a poisonous gas, it's toxic to us, and we've got carbon, which can cause breathing difficulties and lung disease in the long term. So your next task is problem sort. So what I'd like you to do is go back to your student worksheet, type out those bullet points in the correct heading of the table. Pause me, come back once you have done it. Okay, so remember to change your font colour to green because you are going to be self-marking this work. Let's look at the answers then. So complete combustion should have only had 2. Both had 4. Remember, both burn fuels, both make water, and both give out heat and light energy. Now, incomplete combustion had a lot more. You can see that it's limited oxygen, it causes lung disease, it produces carbon and carbon monoxide, causes dirty buildings, it limits the amount of oxygen in the blood, and soot, remember, is just carbon. So finally, there's one more problem that we haven't looked at, and that's what happens if there's an impurity within the fuel that we're burning. So most fuels do contain impurities, and a common impurity that can be found in a fuel is sulfur, which looks like this. Now, you can tell if a fuel contains impurity of sulfur because of the colour and the smell when it burns. Sulfur gives off a really pungent, eggy smell when it reacts. Now, you can see here the colour of the smoke from this power station is yellow. So therefore, it must be producing something different, something other than carbon dioxide or carbon monoxide or carbon. What do you think it's producing? Think about when something burns, it reacts with oxygen. What do you think it's going to make? So we're burning the sulfur in the fuel. It's reacting with oxygen. Sulfur plus oxygen makes, what do we get if we react carbon with oxygen? Carbon dioxide. So sulfur plus oxygen goes to make sulfur dioxide. Now, sulfur dioxide, okay, what do you think the chemical symbol is? SO2. So sulfur reacts with oxygen to make sulfur dioxide. Now, the symbol equation, have a go. Have a go on a bit of scrap paper. Find the chemical symbol for sulfur on the periodic table. You should know oxygen gas. S plus O2 goes to make SO2. Well done if you managed to get that one right. Now, what's the problem with this sulfur dioxide gas, though? We know the problem with carbon dioxide, we know the problem with carbon monoxide, but what's the problem with this little sulfur dioxide molecule here, SO2? What's your problem? Now, the problem with sulfur dioxide is that it can dissolve in water droplets or water vapour in the air. And when it dissolves in water, it actually forms an acidic solution. It forms acid rain. Now remember, guys, you do not need to remember the symbol equations, but I do share them with you because you are top set year 7. So the word equation for when sulfur dioxide dissolves in water is sulfur sulfur dioxide plus water goes to make sulfuric acid. Now you don't need to remember that, you can just call it acid rain. But again, you are top set, so I am introducing you to these new words in science of chemicals that you will use at some point in your school lives, hopefully when we're back in. Now, what do you think the symbol equation is? I don't expect you to know sulfuric acid, but the symbol equation, again, you don't need to remember this, but sulfur dioxide is SO2 plus H2O goes to make H2SO4. But what's the problem with acid rain? Now, acid rain is more acidic than usual. Okay, so rain is ever so slightly acidic anyway. However, acid rain is more acidic. Now, when acid rain falls, it's not so strong that it burns through your skin. It's not corrosive on your skin. However, if items and objects are left out in the elements, in the wind, in the rain, and outside over long periods of time, then acid rain can have negative consequences. So, over longer periods of time, it can turn soil acidic and damage any plants growing in that soil. It can also damage the leaves on trees as well. So, acid rain can actually kill trees. Now remember, this happens over a longer period of time, so it doesn't happen instantly. Acid rain can also fall into water systems and cause the pH levels, the water to become more acidic. Now, anything living in that aquatic ecosystem, for example, in a river or in a lake, can then die because of the acidic levels in the water system. So it can kill trees. It can also damage it can also damage aquatic ecosystems. Aquatic meaning water, ecosystems where animals live and interact. So, for example, in rivers and lakes. And finally, acid rain can also damage limestone statues and metal. So if we look at these two images on the screen, okay, you can see this statue here has been weathered over a long period of time, and that has been caused by acid rain falling on it. And over a long period of time, the acid rain has reacted with the stone, the limestone that it's made out of, and corroded it. Just like we can see with this metal here, it's rusted, but it's also corroded because of the acid rain. So over a long period of time, trees can become damaged. Aquatic ecosystems, for example, fish, become damaged or killed. Statues and metals can also become corroded. So task 3, I want you to go to your student worksheet. I want you to click the link and I want you to watch this video on acid rain. So pause me, go and watch the other video and then come back to me, please. Thank you for coming back. Now let's move on to the next task. So that leads us on to task 4, questions about acid rain. So what I'd like you to do is answer the questions about acid rain by typing your answers onto your student worksheet. Pause this lesson video, come back for your answers. Okay, so what impurity can be found in fuels? Sulfur. Sulfur reacts with oxygen, it forms sulfur dioxide. When sulfur dioxide dissolves in water, it forms acid rain. Any of those problems you could have had caused by acid rain. And then the word equation, I know I've made a typo here and I completely forgot to correct it. See if you can see what the typo is in the word equation. Yes, silly Miss Pitt. Sulfur plus oxygen goes to make sulfur dioxide, not carbon, and water. Now, remember, guys, that should just be sulfur dioxide. So I do apologise about that typo. I will correct it. Make sure you're correcting it or not making that mistake that I've done. I just haven't corrected the products. So sulfur plus oxygen goes to make sulfur dioxide, and the symbol equation should be S plus O2 goes to SO2. Now that brings us on to the consolibobs. So what I would like you to do is to decide if each statement is true or false by writing true or false next to it. And for the false statement, you will need to correct it so that it is true. So pause the lesson video, go and complete this task, come back for your answers. So answers are as follows. The first one was true. Second one was false because incomplete combustion produces carbon monoxide. 3 was false. Carbon dioxide is the greenhouse gas, not oxygen. 4 was false. Acid rain weakens statues or corrodes it or weathers it or breaks it down. 5 was true. 6 was false. The chemical symbol for sulfur dioxide is SO2. 7 was true. 8 was false. Carbon monoxide is toxic to us. It is not safe. Number 9 is true, and number 10 is false. Global warming destroys habitats. It doesn't help protect them. So that leads us on to our final task. And remember, the final task of any good lesson is to review your learning. So the learning intention was to describe the problems caused by combustion. Are you red? Are you amber? Or are you green for that learning intention? So at the bottom of your student worksheet, you've got a section that looks the same as this. All you need to do is write your colour over the dots provided. Thank you for taking the time to access your learning again, Year 7. I hope this video has been easier to use than the dreaded loading loom videos. Thank you, and I look forward to your work being uploaded and shared.